Now we'll try to derive a mathematical expression for an inelastic collision and an elastic collision. Okay. Now, so what we have is, see, look at the figure. So we have an object which is coming and hitting another object. Basically, this is collision. Now, once collision happens, what happens? So these two objects can go in a different direction, correct? So let's call those two as θ1 and θ2. Okay. Now what we'll do is we'll try to calculate the momentum and the kinetic energy for this particular scenario, that is completely inelastic collision. Now, when we talk about completely inelastic collision, see what we have? We have both the quantities, that is the first object and the second object will go in the same velocity, correct? So in this particular case, don't you think θ1 and θ2 will be equal, and that will be equal to 0, correct? So we have now m1 into v1i is equal to m1 plus m2 into vf. Now this is basically conservation of momentum. The initial momentum and the final momentum should be the same. So after this, now vf is the final velocity. Since both of them are moving with the same velocity, we have vf is equal to m1 by m1 plus m2 into v1i, just cross multiplication, right? So we got the final velocity. Now see, there is a loss in kinetic energy, correct? So that loss in the kinetic energy is nothing but the difference in kinetic energies. So we have delta k is equal to half m1 v1i square minus half m1 plus m2 into vf square. So let me tell you what is happening here. The initial system has some kinetic energy. The first object is coming and hitting the second object with some kinetic energy, and once it hits the second object, both of them will move with a certain velocity, correct? So this change in kinetic energy we are calculating. Okay, now coming back to the derivation, we have half m1 v1i square minus half m1 square by m1 plus m2 into vi1 square. Now how we got this is we substituted vf. Okay, 1 m1 plus m2 will get cancelled. This is how we got it, right? Now in this particular formula, half m1 v1i square you can take it common. So we get half m1 v1i square into 1 minus m1 by m1 plus m2, correct? Okay, now after this, so what you do? So you take the LCM, and once you take the LCM, what you get is half m1 m2 by m1 plus m2 into v1i square. Now clearly this is a positive quantity, correct? Because m1 m2 is obviously positive because it's mass, and v1i square, that's a square, it's a square number, so it is also positive. Now what we get from this is the change in kinetic energy is positive, correct? That means the initial kinetic energy has to be more compared to that of the second, correct? Or the final thing. So what we can infer from this is this difference in the kinetic energy comes out as either heat or sound or some other source of energy. So an example what we can give is, suppose let's say you take a ball and you throw it to the wall. Now you will hear the sound, correct? So that sound and the friction which is causing the heat, that is this difference in the kinetic energy. Okay, now this is what happens in a perfectly inelastic collision. Now in the next video you will see the same thing for an elastic collision.